Diffusion, the international science radio show.
We have a bouncer on the doors of perception.
The good, the bad, the ugly.
It gets pretty exciting.
The myths, the truths.
Toxicology.
Astroseismology.
Magnetism. The dark side.
Genetically engineered potatoes.
Planetoid.
Planetoid.
I love that word.
Hello and welcome to Diffusion. Sit back and relax while we inject weird and wonderful science directly into your dreams. I'm Ian Woolf. On this edition, we follow up with William Crowe of High Earth Orbit Robotics and his plans to make asteroid mining easier. But first up, news of giant Tesla batteries that pay for themselves and the new virtual power plant made up of 50,000 rooftop solar systems in South Australia. $1 million a week? The South Australian government installed a giant Tesla battery of 100 megawatt hours in 2017. South Australian taxpayers will have subsidised the cost of the giant Tesla battery by $50 million over the next 10 years. But it's beginning to look like it might pay for itself before then. This is the battery project that Elon Musk personally promised would be built within 100 days or be delivered for free. The 100 megawatt hour Tesla battery on the Hornsdale wind farm near Jamestown in South Australia had to be put into service to help with peak power demand on December 1st, 2017, a day earlier than planned, due to the first heatwave of summer hitting Australia earlier than expected. Frequency control and ancillary services are often required in South Australia because of the failure of ageing coal-fired power plants in the electricity network, compensating and smoothing as they trip and recover in heat waves. Coal and gas plants are thousands of times slower than a Tesla battery, taking 6 seconds to respond instead of milliseconds. Before the Tesla battery at Hornsdale Wind Farm was switched on, South Australia had 10 of these trip events across 12 months, requiring frequency control and ancillary services to smooth the power network, costing $7 million each time. $70 million a year. The Frequency Control and Ancillary Services, FCAS, provided by the Tesla battery earned its owners, Neoen, $4 million, while still costing taxpayers $3 million less than it used to. The ageing coal power plants in South Australia tripped again in the heat of December 14th, 2017, and the Tesla battery jumped in to smooth things out in milliseconds, once again earning $4 million for Neoen. In January 2018, the Australian Energy Market Operator called for generators in South Australia to provide frequency control and ancillary services again. Previously, this would have seen power prices jump to around $14,000 per megawatt. But with the Hornsdale wind farm and the Tesla battery bidding lower than the gas turbine owners, the price stayed near $270 per megawatt. The January event earned $4 million for Neoen again and saved taxpayers another $3 million. On January 13th, 2018, the electricity price went negative for 4 hours. Neoen was paid to charge their own battery at $1,000 per megawatt hour to absorb excess power from the grid, making around $75,000 profit. Neoen were able to sell electricity at around $14,000 per megawatt hour on January 18th and 19th, making $1 million across a few days. This kind of behaviour, instead of repaying the cost in 10 years, may repay the cost in a single year, after which it will be running at a profit. Virtual power to the people. The South Australian Premier Jay Weatherill has announced that the state government are partnering with Tesla again to put solar panels and storage batteries on 50,000 houses, to lower the cost of electricity and to make the supply more stable. The 50,000 solar panels and storage batteries will be networked to act as one virtual power station, generating 250 megawatts of power, and a standby of 650 megawatt hours of storage to the electricity grid, which will provide the equivalent of an immediately accessible standby generator with a capacity of 650 milliwatt hours. The electricity generated by solar power is distributed so that it first goes to the houses hosting the panels, with their excess power fed into the electricity grid. When completed, the virtual power station will generate a fifth of the state's power, which is enough electricity to power about 75,000 homes. In a power interruption, these homes will provide a distributed fail-safe uninterruptible power supply. In a blackout, these homes will keep the lights on. The first steps of the 4.5-year project will be a trial installation on the roofs of 1,100 Housing Trust homes. The South Australian Housing Trust provides public, community and retirement housing with low rent to the state's poorest people. The South Australian Government is delivering lower energy bills first to the people who need it most. People whose houses have the solar panels and battery installed are expected to pay around 30% less for electricity than the regular price, according to analysis by economic consultancy firm Frontier Economics. Once the trials have proved successful, the solar panels and batteries will be installed to the rest of the 24,000 Housing Trust homes at no extra cost to the tenants. Each house in the project will have a 5 kilowatt solar panel, a 13.5 kilowatt hour Powerwall 2 battery, and a smart meter. The wider public will also be encouraged to join the virtual power plant project. The rollout of solar rooftop systems to private homes that have opted in will start in 2019, after the houses have been assessed for suitability by Tesla. Tesla technicians will be looking at whether the roof of the house is shaded, which directions the roof faces, and whether the building can take the weight of installation. If more than 50,000 households register their interest and the trial installations are a success, then the South Australian Government will expand the program. Private households will pay part of the cost of the power system in return for lower bills, and perhaps eventual ownership of the panels and battery. This is still to be worked out. The installation will be by Tesla, but the maintenance and billing will be by a private electricity retailer that hasn't been revealed yet. The South Australian Government say they want to introduce more competition to drive down power prices, so this may be a new electricity retailer. The project was started with a $2 million grant and a $30 million loan from the state government's Renewable Technology Fund. The total value of the project is estimated at about $800 million, the rest of which will come from private investors. The virtual power plant will act as a dispatchable power supply that is quicker, cheaper and more reliable than the equivalent gas or coal power plant, to smooth out disturbances in the electricity grid, much like the Jamestown giant Tesla battery has been doing. The virtual power plant will also get paid to absorb excess power from the grid when electricity prices go negative again. Other states have announced big battery programs, but none have been as innovative as South Australia. You're listening to Ian Woolf on Diffusion Science Radio. Send emails to science@diffusionradio.com. We're brought to you across Australia on the Community Radio Network and podcast over the internet on www.diffusionradio.com.
This is a story of the future, but not the very distant future.
Resources in space. Elon Musk and many others are planning on mining asteroids in outer space for minerals. It's a long way out to the asteroid belt, and the asteroids are spread out across vast distances. William Crowe is an aerospace engineer who's been thinking about asteroid mining for a long time. I first met William in 2015 at the Orbit Oz Space Entrepreneur Meetup group, where he explained his PhD thesis about creating a tiny swarm of robot spacecraft to map out the best asteroids to mine. Here's an excerpt of my discussion with him a year later in 2016 about his company High Earth Orbit Robotics and his brilliant idea of saving time and money by mining the asteroids that come to us, instead of us going to the asteroids.
So in the last 12 months, we know of 40 that came closer than the moon, and there's probably even many more than that we just did not see at all that passed close by.
So if they come that close, doesn't that make it cheaper to mine them than if they're very far away?
Absolutely. So delta V in traditional missions is a lot lower, but what we've found in our company is that you can do very cheap flyby missions of these asteroids. So that allows you to take photographs and spectral images that you wouldn't otherwise be able to get. What we've done is centralized all this free information and also added some graphics, made it a lot easier to know about, and we're actually going to take photos of most of these asteroids as well. You'll only be able to see the pixel, but it'll be an interesting pixel, we hope. In the future, we're looking to have spacecraft that do flyby missions. That's just so we get the high-resolution photos. And we're looking to use ground-based telescopes at the moment, which are great for initially discovering asteroids and also for picking up a little bit of spectral data about the spectrum that's sort of given off by these asteroids.
In late 2017, William gave a talk about asteroid mining for the Spark Festival celebration of the 50th anniversary of space travel. In the talk, he explains how he got interested in asteroid mining and where his company High Earth Orbit Robotics is up to in its plan to map the asteroids that come to Earth.
So there are these giant flying rocks in space that kind of float around and sometimes crash into each other and other planets, and they're called asteroids. Something that's great about asteroids is that they have a variety of minerals on them, including things such as, don't laugh, water and platinum, which are in space strangely worth about the same amount, which is odd. So I'm doing a PhD at the moment, I've just submitted. And during the course of my PhD, I investigated asteroids that are coming really close to Earth, and by that I mean closer than the moon. And I found out that just recently, as of the last few years, there's this new opportunity to visit more asteroids than we have in all of human history to now in just 1 year. And we can do it without even leaving Earth orbit, and a lot more cheaply than we have been able to as well. And that's why I formed High Earth Orbit Robotics. So yeah, it all started with Star Wars. I saw it when I was 12. And then I read a whole bunch of other science fiction, the greats like Isaac Asimov and etc. And then I realized I wasn't very good at doing my schoolwork at home, so I didn't get good grades. And then I realized I didn't mind science, actually. And so I actually did my homework, and then I got very good grades. And then I was kind of empowered to think beyond Earth and do aerospace engineering. And you know, there's a few steps in between, but I've done a PhD and also won a whole bunch of international awards, which is pretty great, and decided to start my own space company. So there were a few gaps in between. I've worked for the railways. You earn really good money there as an engineer, but it totally sucks. And the reason that I went there is because the Australian space industry, up till very recently, has been super opaque. So no one's really known about all the monies that are being spent there. And a dollar amount's being put on it recently, which is that in Australia we spend over $3 billion a year just on buying data from space from other countries. All of that money goes overseas, all of it. And it's opaque because most of it is defense related and big government budgets that the government doesn't want you to know that they're spending a lot of money on. And you know, to be fair, it's very helpful. Like we get a lot of value out of that money. It helps us with our large continent, figuring out what's going on in different places without having to physically go there, which would be vastly more expensive. But yeah, it totally sucks for aspiring space engineers and other people that want to work in the space industry, and it'd be great if we could spend that money in Australia. But now we've had a space agency announced, which is totally fantastic. And also there's a lot of work going on in the space startup sector as well. One thing I found during my undergrad degree, and it turned out to be prescient, but I had no idea at the time, I thought I was just crazy. Asteroid mining is becoming a thing. So this is, the Kerbal Space Program, there's an add-on that you can get where you go mine asteroids, which is pretty cool. But after I did my undergraduate degree a few years later, and I was working the railways, which really sucked, then I went overseas for a year. When I was overseas, these companies came out and they said that they wanted to mine asteroids. These companies are called Planetary Resources and Deep Space Industries. And with Deep Space Industries, at least, a lot of those guys are from Australia as well and have worked in the mining industry here before. But yeah, it's becoming a thing, even though no one's used resources in space before. It's now so real that NASA and ESA, in all of their future plans, just assume that there will be resources for them to use in outer space. So it makes people like me worried in the industry because we've got to rush ahead to get this done, and things are still a little bit behind maybe where they should be. And that's why I started my company, actually, because I was getting pretty fed up with how things were. So I started High Earth Orbit Robotics. So as I said, this started from my PhD work, and there's this opportunity to visit asteroids that are super close to Earth. And if you've got spacecraft that are sitting in high Earth orbit, very original, then they can zoom out just a little way when these asteroids are passing Earth. And just from data last year, there were about 10 asteroids that you could go visit, which is about the number of missions to asteroids to date. And the number could increase greatly if we had improved search programs as well. So we had a bit of a soft launch about a year ago. We had no idea what we were doing. It was me and a bunch of robotics engineers. So we did some design work. Also, we launched a few high-altitude balloons just to test equipment, etc. And then I went back to finish my PhD, and we're about to relaunch again soon. And I guess something that really interests me is how ridiculous it's getting with Earth-based mining. We're spending a lot of money to try and find resources, but not really getting anywhere good. So there's been an epic increase. Is this just in Australia? No, this is in the world, but it's mirrored in Australia. And we're spending ever greater amounts on exploring for resources. We had a bit of a rise just before the GFC, and then it dropped off a little bit, but that's going up again. And we're not really finding many resources, or the resources that we are finding, they're in smaller quantities, so the ore bodies are vastly less than what they were previously. And that really sucks. And you probably, if you want to be a startup going into looking for more resources, you've really got to compete with all these big players who know what they're doing, although are spending a lot more money than they should. Because the thing is, not that many asteroids pass Earth. Last year we had about 53 that came closer than the moon. But as you start imaging and visiting more of these asteroids, the number of other asteroids that this information applies to grows exponentially, and suddenly you have the key to the whole solar system. And we're really interested because while I had my hiatus doing the PhD, companies such as Goldman Sachs have come out and said that they're very interested in the information asymmetry that could eventuate from someone like us going around and doing some very minor missions compared to what's been done before to asteroids, and learning a whole bunch about the entire solar system, really. Right, so for those who don't know, we had the space agency announcement while we were all at the International Astronautical Congress in Adelaide, which was fantastic. And actually, a lot of people from other countries were really excited for us that we finally had a space agency. And I thought they wouldn't, so that was amazing. But what's great about this is that it's making space transparent. So even though some of the $3 billion might still be, given from a closed bank account to another closed bank account, no one really knows about it. At least we'll have a space agency, and that's really a figurehead for people like my younger self who really wanted to do space and didn't really want to leave the country. Another great thing that a lot of people might not know about is that in the middle of Australia, we've got this giant area, larger than most countries, which is dedicated to missile tests or rocket launches as well. And it's a place called Woomera. Has anyone been through the Sturt Highway? Yeah, so you can't leave the road for a whole several hundred kilometers, and that's because you might get hit by a falling missile. But yeah, we've got a great test facility in the middle of Australia, and myself and some other startups are looking to make that accessible and have our own, essentially, Mojave in the middle of the Australian outback. So something that Elon Musk talked about last year, not this year, and I found super evocative, was opening a pizza shop on Mars. And then I was looking on the interwebs this afternoon and discovered that Domino's has already thought this through for the moon. So, yeah, sorry, this one's pixelated as well. But on the left here, that's their concept. So looks like they've used a program like Unity and just made a bit of a virtual reality concept of their Pizza Hut, not Pizza Hut, sorry, Domino's on Mars, on the moon, looking at Earth. Apparently it was the Japanese Domino's, so I don't know. Yeah, but I find that really evocative, and that's kind of a sign of where we need to go, where it's just so common to be a spacefaring civilization that you can just get pizza on the moon or at Mars, wherever you want in the solar system. Also, riding a bike on the moon, I don't know how easy that would be, because spacesuits are notoriously hard to move in, so yeah. And the last one is at the Grand Canyon, but it's a cool space stick selfie at the, what is it, the Marina Valles Marineris on Mars, which is the biggest canyon in the solar system, much larger than the Grand Canyon, and probably doesn't look quite like that, maybe a bit shallower, but yeah. Yeah, that's it, everyone. Thanks so much, and yeah. So yeah, that's really weird. About 2 years ago, they came to an off-Earth mining conference, and we were there. And it was interesting because we really wanted to collaborate them, i.e. take their money. But they were concerned that there wasn't a place for them, and they didn't know, and we hadn't determined how they could be valuable to us in other ways. And what's happened in the last 2 years is that we've come a long way, and people like myself in the off-Earth mining community are really interested to work with them to look at things like environmental concerns, to look at things like how to get community support, and things of that nature, which the mining community is very good at. The other thing is, we're not sure if we should call it mines anymore, because people keep getting freaked out that we'll have this giant gaping copper hole on the moon. You'd have to be pretty big to see from Earth, but people are concerned about it all the same. And they're rightly concerned. And it's probably more like going to be a well to begin with, because you don't need to extract a lot to get a lot of value. There's been a price set on water on the moon. I think it's $1 million per cubic meter of water, of liquid water. So it's pretty epic. Better than that, there are deep sea mining startups that are just coming into the picture. So there's a company called Nautilus that we're very interested in working with. And their domain is working with large mining companies and in a similarly obscure place. So yeah, that collaboration is very interesting. The other way we're collaborating is with universities who have only just, believe it or not, got on board with this. I think it was very weird for a lot of people. They were like, why hasn't NASA done this already? And the answer was, not enough people were looking up and looking for a lot of asteroids coming close. And it took a meteor exploding over a Russian city and injuring 2,000 people for us to look good enough, Chelyabinsk, that's the one, for us to look well enough to identify enough asteroids to make a technique like this worthwhile. But now that it's worthwhile, it's really worthwhile. And yes, anyone who's interested in information asymmetry, which seems to be everyone these days, then that's the thing to do, I think. Fantastic. Well, thanks so much, everyone, and catch you later on.
That was William Crowe talking about mining the asteroids that come near Earth. And that's all from us this week on Diffusion. Would you like to hear your voice on radio? Record a voice memo on your phone or use the voicemail tab on the website. We need more people contributing stories to Diffusion. Send your contributions, opinions, helpful suggestions and donations to science@diffusionradio.com. That's science diffusionradio.com, and please do send me an email so I know you're listening and you'd like to hear more episodes. Please like the Diffusion Science Radio page on Facebook and rate us on iTunes. Tell your friends. Follow me on Twitter @Ian Woolf. Join my patrons in supporting the show at patreon.com/diffusionradio. The news music was Rhinos Theme by Kevin MacLeod of Incompetech.com. Sound and fact-checking by Charles Willock. I produce Diffusion, which is broadcast around Australia to 27 stations on the Community Radio Network, including 2RBM in the Blue Mountains of New South Wales, 8CCC in Alice Springs and Tennant Creek, 2MVR in Nambucca Valley, and 3MBR in the Mallee Border districts of Victoria and South Australia. Diffusion is syndicated globally on the National Science Foundation's Science 360 internet radio station and also on astronomy.fm. Subscribe to the podcast on the Diffusion website, www.diffusionradio.com. That's www.diffusionradio.com, and check the website for links, photos and videos about this week's show. If you enjoyed the show, you can explore more than 900 previous episodes archived on diffusionradio.com, where the shows are labelled by keywords so you can focus in on the stories you want to hear. Subscribe to the Diffusion YouTube channel at youtube.com/c/diffusionradio. I'm Ian Woolf. Join us inside your audio device of choice for more science wondering next week on Diffusion Science Radio.
Science is fun. It helps you to learn, to know, and to appreciate. When you study science, you may go on field trips. You discover the marvelous interrelationships between all living things. You learn to read the history of the Earth as it is written in rocks and fossils. You find out what makes things tick, everything from a molecule to a living organism. In the study of science is found the most useful and satisfying knowledge of man. Knowledge of his physical world, its past, its present, and its future. And in your moments of relaxation, now and in the years to come, you will find the study of science leading you into fascinating pursuits. Photography, collecting. Why study science? Study science because you will find in the study of science a richer, more rewarding life.